How's everybody doing? Good. Yeah, feel free. I mean, there's all kinds of different snacks and refreshments over there. But yeah, we'll just go ahead and get started. So, welcome, and thank you everybody for being here. My name is Dr. Prins. So I work within the exercise science department, and the topic for today's talk is going to be about nutrition and weight management. And I'm going to be sharing a lot of information with you in the course of the next 50 or 60 minutes. And really my job is I'm a researcher. So what you're going to see is I'm going to present the research to you, and then by the end of this talk you can make up your mind, okay? But that's really my job. And also just a quick disclosure, I have no conflicts of interest, and as we go through this talk, a lot of you may be going, wow, this information that he is sharing with me seems very polar opposite to what I've heard before, to what my doctor or nutritionist have told me. And that's okay, right? Because I'm going to show you the evidence. I'm going to present to you the facts. Now, I've been involved in the field of nutrition, probably studying it in depth and doing research here for the last decade or so. And one thing I can tell you is that I don't know about any other field with nutrition where there's so much misinformation. So I'm going to try to make things a little bit clearer to you and show you the science and show you the evidence. Okay? So I always tell my students, everybody's entitled to their own opinions, but you're not entitled to your own set of facts. So I'm going to show you some facts. Okay? So let's start off with some statistics. Okay? So I don't know how many of you know this, but there's a chronic disease epidemic in the United States where we have half of all adults have one or more chronic health conditions. When I mean chronic health conditions, I mean obesity, cancer, heart disease, diabetes, Parkinson's, dementia, arthritis, etc., etc., etc. That's a lot of people. And this chronic disease epidemic really stems from the fact that we have an obesity epidemic. We have about a third of adults in the United States are obese. And then we have about 70%, that's 70% of adults are either overweight or obese. Okay? It's not just a problem in the United States, it's also a global problem. So if you look globally, about 3/4 of the global population are also overweight or obese. That's somewhere between 4.5 and 5.5 billion people. And again, what's going on here, it's when you have this excess fat accumulation, you have what's known as insulin resistance, and you have chronic inflammation. And those are really the root causes behind many of these chronic health conditions. There's also the cost associated, right, with the weight gain. And so you can see up there, the medical costs linked to obesity is about $150 billion. Per capita medical spending is about $1,500 a year more for an obese person compared to a normal weight person. So let me show you this graph over here. So this looks at the obesity trends, right, going back to a couple of decades ago, back to the 1960s. So if you look at here the 1960s and you look at male and female obesity rates back then, you see it was somewhere between about 10 and 15%. So that's not wonderful, but it's also not 40% because currently it's about 40%. So you go and look from 1960 up until the 1980s, and what do you see? You see this kind of very slow, gradual increase. Right, but then all of a sudden, here by the 1980s, you see this kind of inflection point where there's this big exponential increase in obesity for males and females. That's why I have that arrow right there, and I'm posing the question, what happened here? Right? Did all of a sudden our human genome just change, and all of a sudden overnight we've become more susceptible to gaining weight? Or was there something in the environment that changed over that same period of time? That's important. We'll come back to it. Okay? This is the article that I referenced by saying that currently adult obesity in the United States is about 40%, okay, or more specifically about 37.9. So if you want to round it up, it's about 40%. This article over here is really interesting because it shows us trends in adult body mass index from 1975, the top map, and 2014, the bottom map, in over 19 million people. Okay, so body mass index It's such an easy calculation, right? You can just Google body mass index calculator. You put in your height, you put in your weight, and now you know your BMI, okay? And you can see if you're normal weight or overweight or obese, okay? And so they looked at, this is global BMI. Global BMI in 1975, 21.7. In 2014, 24.2. That is a significant increase in global BMI in such a relatively short period of time. So again, how did that happen? How do we go from people starving, not getting enough food, to an obesity epidemic in such a short period of time? This just shows you trends. So if projected rates of obesity by 2030, meaning so if the current trends continue by the year 2030, again, that's not that far from now, right? And the United States will be leading the charge. We'll be close to, just over 45%, so close to 50% of the adult population would be obese, okay? So I wanted to start off with that. So make sure everybody's on the same page, right? We have a chronic disease epidemic that is kind of fueled by the obesity epidemic, or the fact that we have 70% of the population overweight or obese. So next, very importantly, I want to talk about the biology or the physiology of weight gain, right? Why do we gain weight, right? This is the most important question. Because if we get this question wrong, then all the other treatments will also be wrong. So it's very easy for me to make the argument that our current health experts, nutritionists, and medical practitioners do not have a very good idea of what causes weight gain. If they did, things won't look like this. It would be going in the opposite direction. So it's not that hard to say most people, not all people, but most people in the healthcare industry do not have a good understanding of what causes weight gain. So let's look a little bit at the biology, right? Why do we gain weight? So I have this illustration right here on the slide, and this illustration has got nothing to do with evolution or anything like that. The idea behind this picture, especially if you look at the guy over to the left, the point that I'm trying to make is that human beings, right, created by God, has been around on planet Earth for a long period of time. Whether you think it's 6,000 years, 10,000 years, millions of years, it's a long period of time, right? So for that long period of time, we were lean and healthy, right? When God created us, He didn't create us with, chronic diseases and obesity. So why for most of human history were we lean and healthy? The answer is because we have an apostat. An apostat is part of your brain that controls energy balance. It controls energy in versus energy out. You think you have it under your direct conscious control, but you do not. Okay? It's another homeostatic regulated system, just like heart rate and blood pressure and blood glucose, all these other things. So this guy has a normally functioning apostat, and it's very accurate. It has to be. Okay? Now you take a look at the guy over there to the right, just kind of your average Joe. Well, what's wrong with him? Well, it must be that his apostat, that part of the brain that's controlling energy in versus energy out, is broken. Okay? Because this guy on the right has got one characteristic. He is always hungry. So if you want to understand obesity, you have to understand, why is he always hungry? So let's get into a little bit more about the biology here of this apostat function. Okay, so right here at the base of your brain, kind of the last cubic centimeter or so, you have your hypothalamus, or you have your ventromedial hypothalamus, and it serves the executive function of energy in versus energy out. Again, not under your direct conscious control. Okay, so. And this energy in versus energy out is controlled by important hormones, as you see over here to the left, like the hormones leptin and insulin. So meaning, say I decide to be sedentary. Okay, so my apostat is working normally, and I decide I don't like to be physically active. Well, what's going to happen is I should not gain weight, because what's going to happen if my apostat is not working as it should be? I'm just not going to bring in that much energy. I'm not going to get that. I'm not going to feel hunger. Right, so frequently. The same is true if I decide to do a lot of physical activity. So I'm expending a lot of calories. What's going to happen is I will just bring in more calories, right? You remain weight neutral. That's how it happens. And these different hormones are controlling this. For example, leptin. Leptin is made and released from your fat cells. Okay, so leptin is made and released from your fat cells. Once it's released and it goes in your circulation, it goes in your blood, it travels up towards the brain, and once it gets to the brain, it tells the brain enough energy has been stored in your fat tissue. And so it tells the brain, okay, you're full, stop eating. That's how these things work. So how about what goes on the flip side of this, right? So what if this system is not working so good anymore? So what's happening in this case, right, if your apostat or this homeostat is not working anymore, because think about it, right, if somebody, again, if you're overweight or you're obese, you have a lot of fat cells, and so you might be going, well, then you're really producing a lot of that leptin, so then you should be really feeling full the whole time, but that's not happening. And the reason why it's not happening is, yes, you have a lot of leptin that's being produced from the fat cells, but it's not getting to the brain. The leptin signal is not getting through. Something is blocking leptin signal from getting to the brain, and that something is insulin. And we'll be talking a lot more about insulin going forward. So most people are what's known as leptin resistant. Okay? So they're producing leptin, but the brain can't see it. If the brain can't see the leptin, it's going, hang on, you must be starving. Hang on, you're not full, right? So what is the outcomes of that going to be? The outcomes is, well, you're going to feel hungry, right? So the brain is going to decide, okay, I'm going to make you more hungry. I'm going to increase your energy intake. Or it can decide to make you tired and fatigued and decrease your metabolism. Those are the outcomes we associate with obesity, the slothfulness and the gluttony, right? So you go see your doctor, and the doctor goes, well, I know why you're overweight. You're a sloth and you're a glutton. You're so lazy, and you like to eat, right? That's how they simplify it. No, that's not true. The biochemistry comes first, and then the behaviors we associate with obesity are secondary. They go the other way around, okay? So the biology or the biochemistry comes first, and then the behaviors we associate with obesity are secondary. That's important. We'll come back to it. All right. First off, I want to show you what is the traditional model of how have we treated this problem, this weight gain problem over the course of the last 3 or 4 decades. We'll just call it the calorie balance theory of obesity. And this calorie balance theory of obesity, it's all about the calories, okay? It's all about the calories, right? It's about calories in versus calories out, right? So calories in comes from the food that you eat, and the food that you eat, right, is your macronutrients, either carbohydrate, protein, or fat. And then your energy expenditure, your energy out, it's actually mostly your resting metabolic rate, okay? So your resting metabolic rate is actually the big component. About 2/3 of your energy expenditure is just your metabolism, just the energy that's needed to sustain normal daily physiological functions. Obviously, then there's also activity, any type of movement, and that's going to be variable depending on how much or little you're doing. But a point I'm trying to get across is your metabolism. That's the big component of your energy expenditure. So I can take you to our lab right now, and I can calculate this, right? I can assess your diet information, put it into a program. I can assess your, hook you up to a machine and get your resting metabolic rate. I can get all this stuff, right? And then I can, based upon the numbers, I can see, oh, you're gaining weight, oh, you're losing weight, right? Which way is the scale going, right? So what's the problem with this, right? So if you believe in this particular model, right, of weight gain or obesity, you go, oh, I know what's the cause. I know what's the cause. It's the overeating and the physical inactivity. Again, it's the slothfulness and the gluttony, right, that's causing this energy surplus, which in turn is, now you have this energy surplus, right, you're taking in more than you're expending, and therefore you're gaining weight, okay? So what would the solutions be? What would the solutions be if you subscribe to this model or way of thinking? The solutions would be really easy. You don't have to be a rocket scientist to figure this one out. The solutions would be to eat less, right, and move more. That's the solutions. Eat less, move more. And that's what people are told. You go see your doctor. Doctor tells you, well, you need to lose weight. You need to eat less, move more. And that's why I have here on the slide failure, right, big capital letters, because people know it doesn't work. So can I show you any evidence for, that shows you that it's a dismal failure? Yeah, let me show you the best evidence. This study over here, this Women Health Initiative dietary modification trial, It was done, this was published in 2006. It's not even a new study. It's just people don't bother to look for it. And this was one of the most expensive nutritional or dietary studies ever done. Okay, it cost the taxpayer about close to $1 billion. Why? Because it was 50,000 women, and it was close to a 10-year period. So a study like this, they will never spend that much money on it. It just takes too long. It's too expensive, right? So what they did is they took these 50,000 women and they randomized them to two groups. One group was just a control group, so it was like, just do whatever you want to do. And the other group was the intervention group. We'll just call it the Eat Less, Move More group. And for that group, they did a couple of things. They said, for you guys, we want you to eat less calories from fat, so eat less fat, eat more fruits and vegetables and whole grains, so eat more calories coming from carbohydrate, be more physically active, right? And so that's what they did, okay? And if you look at the results from the study, you can see that they did restrict their calories. So they were eating less, on average by about 360 calories per day. They did eat less energy from fat, and they did eat they did eat more energy coming from carbohydrate. And they were more physically active. The question, though, is, did they lose weight, right? So over here to the left, that shows you the weight change over this study period. So the white or the blank circles, that's the control group. So you can see their weight stayed fairly stable. The black circles, that's the Eat Less, Move More group. So you can see during the first year, right, during the first year, they saw on average about a 2-kilogram weight loss, but then it came right back. And by the end of the study, there was absolutely no difference between these two groups. No difference. That's why I said failure. Okay? People know it's a failure. People have tried this. And this is the best evidence, the longest, most expensive study to show you that it does not work. I can actually make a good argument that the people in the Eat Less, Move More group actually gained weight. Because if you look at their waist circumference and their waist to hip ratio, it actually increased. So any tiny amount of weight that they might have lost during this period was probably muscle, and they gained fat around their midsection. So the next question becomes, why doesn't it work? It seems so simple. It seems so obvious. All you have to do is eat less, move more. Why doesn't it work, right? And so this study over here, a fairly recent study, persistent metabolic adaptation 6 years after the Biggest Loser competition, provides us some mechanistic insight into the why, right? Because most of you probably have either heard or seen the Biggest Loser show, right? And so you have people who are obese who are in the show, and while they're in the show, right, they undergo a rigorous diet and exercise regimen, right? So it's basically a eat less, move more on steroids, right? That's what they're doing. And sure, during the show, they're losing a lot of weight, but who's checking up with these people, a couple of years down the line? And so this is what this study did. They looked at their weight, but they also looked at their resting metabolic rate, the biggest part of your energy expenditure. So here's what they found is, not surprisingly, everybody gained the weight back. But why? So they looked at their resting metabolic rate, right, during the show and then 6 years later. And what they found is their metabolism decreased. It went down on average by about 700 kilocalories per day. That's a big decrease in their energy expenditure. So this is why it doesn't work, right? Because when you do this moderate form of caloric restriction, right, so you bring in less energy. Your brain is not stupid. It knows what you're doing. So your brain starts to decrease, or it starts to slow your metabolism down. It has to. If it doesn't, you'll run out of energy and you die. So it starts to bring down your metabolism. However, what studies like this is showing us is it might go down in the short term, but it looks like it's staying down in the long term, right? And so this is what happens. You go on this diet, or you follow this advice, and you put up a Herculean effort, right? You try your best, right? And maybe it takes a couple of months, right? And you go, I can't do this anymore. I can't do this. I feel tired. I kind of feel like crap, right? Plus, I feel hungry the whole time, okay? Well, you're feeling hungry because your hunger hormones have gone through the roof. You feel tired and sluggish because your metabolism has decreased, right? So then you go back to the doctor, and now you gained the weight back, right? Because it's so easy for you to, if you go off the diet, right, you gain all the weight back again because your metabolism is now down here. It used to be up here, but now it's down here, so it's so easy to gain the weight back. You go back to the doctor, and the doctor says, well, I know why you gained the weight back, because you went off the diet. No, the problem is the advice. It was horrible advice to begin with, okay? So it's the advice giver, right, that is giving the wrong advice. Okay. So if it's not all about calories, because you have to understand there's differences between proximate causes and ultimate causes. So we always want to look at what is the ultimate cause of disease, or in this case, weight gain. Okay, it's not calories. Calories are the proximate cause of weight gain. It's not the ultimate cause of weight gain. What's the ultimate cause of weight gain? It's hormonal. More specifically, it's insulin. Okay? Insulin is produced from your pancreas. Okay? And insulin is a storage hormone. So is there any evidence that I can show you that insulin causes weight gain? Sure, here's just one example. So this comes from the Diabetes Control and Complications trial. And this is in type 1 diabetics. If you're type 1 diabetic, you don't produce insulin from your pancreas anymore, so you have to take insulin right via injection. So what they did over here is they took a couple of thousand people and they randomized them either to just a conventional insulin therapy group or an intensive insulin therapy group. So the intensive insulin therapy group got more insulin. So what they found is the more insulin they were given, the more weight they gained. And people who take insulin know this. They gain weight. So then you go, well, I'm not diabetic. I'm not taking insulin. What's your point here? The point is most people's lifestyle is sufficient to mimic that same response. Okay? Most people's lifestyle is sufficient to mimic that same response. How so? It's your diet, right? So you have, when you eat something, right, you have the 3 macronutrients, right? Carbohydrate, protein, or fat. Now, as you can see here, they have a different effect on your insulin levels. When you eat a high carbohydrate meal, your insulin, right, is much more pronounced, right? You see a much bigger effect, okay? For protein, it's a little bit less so, and for fat, it's even least so. So you combine that very simple piece of biology, you combine it with these two facts, and I'm going to show you this here in a little bit, that most of us, not just in the States, but also globally, eat a diet that's very high in carbohydrate, okay? So we eat these high carbohydrate diets, plus we eat quite frequently throughout the day, right? Breakfast, lunch, and dinner, and all kinds of snacks in between. You combine those two facts, okay, with this. What do you get? You get insulin that is being released, right, from your pancreas in quite large amounts and in quite frequently. So now you have your insulin levels over here throughout the day. So you take that scenario and you play it out, right, because this doesn't happen overnight. You play it out over the course of a couple of weeks or week after week, month after month, year after year, decade after decade. What do you get? You get weight gain. You get chronic disease, right? That's how it happens. So rather than this caloric balance theory of obesity, we rather have this fat cell theory of obesity. This is a much better model to look at it. So right here to the left, we have the chief culprit. It's these processed carbohydrates, right, that so many of us are eating. Because those processed carbohydrates, right, so like, for example, the sugar, I'm not talking about, say, broccoli or cauliflower, is those processed carbohydrates has a really big impact on insulin. So this is not going to happen overnight, but if you have a lot of insulin being secreted quite frequently over a long period of time, it is going to result in fat storage. So think of insulin as a fat cell fertilizer, okay? It's going to make those fat cells grow, plus it can create new fat cells. It's like, hey, these fat cells are running out of space. Let me create some new fat cells to help you out here, okay? So that's what insulin does, okay? So once you have this going on over a long period of time, you have dysregulation of your fat cells. There's dysregulation going on of your fat cells, and obviously insulin is playing a big role here. So once your adipose tissue, which is your fat cells, are dysregulated, what's going on? It starts to hoard all your calories. So now you eat something, and it's going zoop right in your fat cells. So your fat cells are hoarding, stealing all the calories. So your rest of your body is going, hey, what? All the other cells in your body is going, hey, what about us? Especially your brain, because your brain takes up a significant amount of energy just on a daily basis. So your brain starts to send off these emergency alarm signals. It's going, hey, I need energy too. And so the brain can do one or two things, right? It can increase your hunger and food cravings, right, resulting in increased energy intake, or it can make you tired, fatigued, slow your metabolism, right, resulting in decreased energy expenditure. So right here at the end of this, right, we have these behaviors that we associate with obesity, right, the slothfulness and the gluttony. But those do not cause obesity, okay? They do not cause weight gain. They are the result of the biochemical processes that preceded it. Most people have this the other way around because they don't understand the biology, right? You have to look into it and go, those are the outcomes, okay? What is the ultimate cause? It's over here, right? With insulin. All right. So what I want to do next is get into a little bit more detail about, again, what are the problems, right? What is the instigator of this? You know, what is the contributors to this chronic disease epidemic, obesity epidemic, et cetera, et cetera. So one of the main problems is the advice and recommendations that most people are getting. Most people are getting the worst dietary advice out there, okay? And it all started back in 1977, okay? So if we go back to 1977, the US government decided that it's time that we come up with some dietary guidelines that all Americans can follow, okay? So we decided, okay, let's come up with some dietary guidelines. That way everybody knows how to eat a healthy diet to stay lean, right, and avoid, you know, chronic ill health, okay? So that happened in 1977, 1980. And it looks like this, right? So we're all familiar, right, with the food permit, and they're saying you should eat all these foods here at the bottom, right? The bread, the cereal, the pasta, so those are healthy. And the things there at the top, stay away from it because it's going to make you fat and it's going to give you chronic diseases. So the introduction of this 1977 dietary guidelines introduced the world to what's known as lipophobia, the fear of fat. And it worked perfectly, right? Because everybody bought into it. Everybody went, hey, I'm going to buy low-fat products, right? Because that's healthy. Fat is bad. So everybody bought into it, and it's very interesting because there you can see the little arrows I made right there. So we have the inception of those first dietary guidelines, and it seems to correspond with this inflection point in, again, weight gain and obesity. So you have to ask yourself the question, is that coincidence, right? Or something else going on here, right? So then, but then people go, you know, it's not the dietary guidelines' fault. You know, again, it's your fault because you're not following the amazing advice. So you're going to go, you know, well, that's nonsense because if you look at the food consumption data, you will see that people are following the dietary advice, whether they know it or not. So again, if you go back to the 1970s, you'll see up to kind of present time, you'll see vegetable intake has gone up, fruit intake has gone up, grain intake has gone up substantially, and vegetable oil intake has gone up tremendously. There's nothing, by the way, just side note, there's nothing healthy about vegetable oils, okay? It's not made from vegetables, okay? It is this processed seed oil. It causes inflammation. And if we know one thing about chronic diseases, the common denominator is inflammation, okay? So you want to stay away from that. But people used to cook in lard and butter, and then they said, no, that's bad. And then everything now is made in vegetable oil. It's just making things worse. So look at the same time, look at the items that's decreased, okay? So red meat has gone down, eggs down, animal fats down, whole milk down, butter down. So all these food items that contains, you know, more fat has decreased. So we're sitting today with a chronic disease and obesity epidemic, and people are still blaming those types of food, right? Come on, like we can figure this out. Those foods, we are eating less of them, but we're not getting healthier. Doesn't make any sense, right? And this is a great article over here, this statistical review of U.S. macronutrient consumption data from 1965 to 2011. And what it shows you, again, in terms of carbohydrate and fat, you can see carbohydrate intake has increased significantly, right, over the course of the last couple of decades, and fat intake has gone down, right? So yeah, we have eaten more carbohydrate and we've eaten less fat. And yeah, I mean, it's very interesting. If you look at the first data point here, 1965, look, people were eating more fat in the diet and less carbohydrate. And you go back to 1975, people were more leaner and healthier than they were today, right? So, and also take a look over here to the figure on the right. That just shows you where most of us are getting our calories from. Again, it's these food items that contain a lot of sugar, flour, and grain, okay? The desserts, the breads, the sodas, the pizzas, that kind of stuff. Again, think what effect that's going to have on insulin and weight gain. And again, this article, they just basically said by the end of this article, the authors basically said that, you know what, people have been following the dietary advice, is that it just seems that it has come at a cost, right? The cost of weight gain and obesity, chronic diseases, etc. Right? And again, this is the problem. Most people's diet, most people's staple diet consists of this sugar, flour, and grain-based product. This is nutrient poor. If most of your calories is coming from these type of items, you're not getting the essential vitamins and minerals that you need, okay? It's a nutrient poor diet. Sugar, right? Some people say sugar is the worst culprit, okay? So what I did on this slide is I just included some commonly consumed breakfast cereals and the amount of sugar contained within. So maybe you really like Cocoa Pops, okay? So you start off your morning with a bowl of Cocoa Pops, and now you have 3, 4, 5, 6, 7 teaspoons of sugar just from the start. You're starting your day with that. And then you have the snack, then you have the lunch, and then you have another snack, and then you have a dinner, and then you maybe have another snack. By the end of the day, you probably have consumed 20, 30, 40, 50 teaspoons of sugar by the end of that day. What would that look like in a week, a month, a year, a decade, right? Any wonder we have obesity and chronic disease epidemic. All right. The other problem is that a lot of people are eating a high carbohydrate diet, but a lot of people are also eating a high carbohydrate and a high fat diet together. So I think you'll find this interesting. So when you look at the research that they do on animals, okay, and they purposely make the animal fat, say the rodent, right? Because you can't do that with humans, right? It's unethical. But you can do that with a mouse or a rat. So they have this obesogenic rodent chow that they feed them, right? And so look at the macronutrient breakdown. It's very low protein, and you can see the fat and carbohydrate are kind of close to one another. But also look at the overall grams, right? So the overall grams of those 3 macronutrients, okay? Take a look at the figure to the right. That is data coming from right here, okay? So right now, we started this last semester. So last semester, we started a study that looks at how people eat and how it impacts their health. Okay, and that study is still ongoing. But I wanted to show you some preliminary data. So this is data from about 30 subjects that we have so far. Okay, and this is kind of the standard American diet or the SAD diet just because it's kind of sad. And so so you see the protein intake is low, and again the fat and the carbohydrate are kind of close to one another. Again, most of our subjects so far has been students, but also faculty and staff members. So I'm not showing you some foreign data from another country. It's right here, right? Grove City. Does it look familiar, right? Kind of like it's mimicking this diet over here with this obesogenic rodent chow. So it's very interesting. It's like we figured out how to make animals fat, and it seems to be the same diet that makes people fat. And then you go, well, I wonder what's the fat in this obesogenic rodent chow, right? Because you have different types of fat. It's vegetable oils. I wonder what's the carbohydrate in here. It's sugar, right? So it's basically like eating a donut, right? It's vegetable oil and sugar. Okay, that's what you're getting. I don't know what the vegetable oil consumption is currently in our study, but I do know what our average subject is consuming in terms of sugar. Our average subject is consuming close to 30 teaspoons of sugar a day. Okay, some of them 40 or 50 teaspoons of sugar a day. When I sit down with a person, like, look, you're consuming 30, 40, 50 teaspoons of sugar a day. Do you know this? They have absolutely no idea because the sugar is hidden, right? You don't know that you're getting in that amount of sugar. All right. This gets a little technical, but this basically is the biology of why this is bad, a high carbohydrate and high fat diet. And the reason why it's bad because it's your mitochondria, right? That's kind of where your body is producing energy or ATP. And so the problem is if you eat a lot of carbohydrate, right? The carbohydrate is broken down to glucose. And so what's going to happen to that glucose? It has to be stored somewhere. And your body has a limited capacity to store glucose. Plus, your body does not want that glucose to be in the blood. It's toxic. So it tries to get it out of the blood, so it stores it away in muscle and liver and stuff like that. But if you're eating a lot of carbohydrate, meaning you have a lot of glucose that's entering the cell, basically what that's telling the cells, it's telling them, hey, it's time to start making fat. So you eat all that glucose, you start to make fat. That's what you see over here. So there's an increase in fatty acid synthesis. And a byproduct of that actually blocks this guy over here, CPT1. And CPT1, if that is blocked, it blocks fat oxidation. Meaning, the short of this, if you're eating carbohydrates the whole day long, you're not burning any fat at all. So a person who wants to lose weight, what do they want to burn? Do they want to burn glucose or do they want to burn fat for fuel? You want to burn fat. But this is why it doesn't work, okay? And it's not really the high fat. It's not the fat in the diet. It's the carbohydrate that's controlling kind of this intracellular mixture of fuels. But anyways. And then the other thing I want to talk quickly about is it's the meal frequency, okay? So if you were to think back to when you were younger or just even talk to your parents, right? So what were you guys eating or how often were you eating when you were younger? So they will probably tell you maybe we had 2 to 3 meals per day. And then you say, well, how often were you snacking? And they'd be like, well, we didn't snack at all, right? And today it's the opposite. Again, we have data from our own study that shows our subjects are eating 2 to 3 days per week. 2 to 3 meals per day, and are snacking again 2 to 3 snacks per day. Okay, and this is what happens, right? So here, this looks at your insulin, right? So again, you have the breakfast, lunch, and the dinner, and you have the snacks in between. And for most people, that's fairly high in carbohydrate. So your insulin levels are going to be high, or your insulin is going to be secreted, again, quite frequently and in quite high amounts. And so if we take one of these little snippets out and we blow it up to what you see here on the right, that's what you get. Because when you eat, again, this high carbohydrate meal, the carbohydrate is broken down to glucose, right? And now you see this big glucose spike. So what happens, again, insulin is secreted because that's insulin's job. It goes, come here, glucose, I'm going to stuff you in the liver and in the muscle. And it's a very interesting point. As you're sitting there right now, you only have about 2 teaspoons of sugar in your blood, about 5 grams. Okay? When you eat, most people when they sit down and they eat a meal, they're consuming a meal that's 50 grams, 100 grams, maybe 150 grams of carbohydrate, which is broken down to glucose. Wow, so now you're going from, in your blood, 5 grams, only a couple of teaspoons, and now it's going all the way up to here. Does that sound like a normal physiological response, right, to be eating that much carbohydrate? That's why your pancreas is secreting insulin to get all that glucose out of the circulation, to stuff it back in, say, the liver or the muscle, or to stuff it back into the fat tissue, right? Now you have fat accumulation. So when you have this high insulin, right, levels, it's going to do 3 things, right? It blocks fat breakdown, it blocks fat burning, and it stimulates fat storage. Does that sound like weight loss advice or weight gain advice, right? And then a couple hours later, you have this glucose crash, and that glucose crash is just going to trigger more hunger. So you're stuck in this remorseless cycle of glucose dependence and hunger. Okay? I'm just going to skip through a couple slides. So there you go. So there are some of the problems. So what I want to do next is look at some of the solutions. Okay? So we clearly see one of the big reasons why we're in the mess that we're in is because of the advice and recommendations that a lot of us are getting. Okay? So maybe what we should do is maybe do the opposite. Maybe we should not follow the advice that we're getting. Why? Because, well, again, what is the ultimate cause of weight gain? It's insulin. Okay? So what raises insulin? Again, there's high carbohydrate meals and, again, eating quite frequently throughout the day. So those are the 2 main things that we talked about. So then it becomes, okay, what would the solutions be? Well, how can I lower my insulin? Well, I can eat a low carbohydrate diet, or I can practice what's known as intermittent fasting. And those are the two solutions I want to quickly talk about. All right. So before I get there, this is a very important point, okay? And this all ties back into what I'm going to say. What is really interesting is to know what diet suits us as human beings best, okay? Meaning, is there any way for us to figure out, right, if we were to go back 1,000 years or 6,000 years, what were we eating for most of human history, right? So meaning, what diet is compatible with our biology, right? And that's why I have this quote up here. Each species can eat only that for which has been genetically programmed as a consequence of its coevolution with a specific group of foodstuffs with a specific environment. Basically what that's saying, if we can figure out what foodstuffs a specific group or species has co-evolved over the course of thousands of years, then you know what diet suits them best. Meaning, say a lion. Well, lions are carnivores, right? They eat a meat-based diet. So that's the diet for them, right? A zebra is eating grass or whatever else zebras are eating, so that's the diet for them, right? However, if we were to take the lion's diet and feed it to the zebra, or the zebra's diet and feed it to the lion, both will probably die, right? Or they'll just have some really bad health effects. So you see the point I'm making. What about us, right? So it's kind of hard to figure out, right? Because we don't have a time machine to go back, but this article right here provides us some insight, right? Because they looked at hunter-gatherer diets, because for most of human history, right, we had to go out and get the food, right? Today it's just open fridge and you have the food there. So for most of human history, right, for about 99.5% of human history, right, you had to get the food. Only the last 0.5% since the agricultural period has things been a little bit differently. So what they found is they said whenever and wherever it was ecologically possible, hunter-gatherers would have consumed high amounts of animal food. Most hunter-gatherer societies worldwide derived over 50% of their subsistence from animal foods, whereas only 13.5% of these societies derive more than half of their subsistence from gathered plant food. So basically what they're saying, it seems that for most of human history, we were eating more of a lower carbohydrate type of diet. They also made an excellent point that the foods so most of us these days consume a diet, but where about 60% of our calories are coming from sugar, flour, and grain-based products. Those would have been non-existent, right? Over here. Here's a carbohydrate consumption timeline. So you can look over the course of thousands of years, you can see the carbohydrate intake where it's been fairly stable and fairly low. But then you look over here to the 20th century, you go, oh, what's going on over here? What's going on over here is there's been this big dramatic increase in our carbohydrate consumption very recently. That's why I have the quote that says, if we are looking for a dietary cause of some of the ills of civilization, then we should look at the most significant changes in man's diet. So where's the significant changes in man's diet? Well, it's right there, right? It's not that hard to figure it out. Here, one more thing. Very interesting, if you look at what are the most obese nations on the planet, it's actually these island nations. American Samoa, Tokelau, Tonga, etc. Very high obesity rate, about 60-70% of the population are obese. And again, this was not always the case. If you go back a couple of hundred years ago, they were lean and healthy. And so you go, well, what did they used to eat? You know, because obviously it's an island nation, they're secluded. So they used to eat basically fish, coconuts, and that was kind of it. Okay? And then things changed. They were introduced to the industrialized or westernized diet. They started doing trading, sugar, flour, and grain stuff. And all of a sudden, overnight, came the obesity, came the chronic disease. See, that's the argument I'm trying to make, is the diet that we are currently eating is fairly new to human history, and it's incompatible with our human biology. What do you think is going to happen if you feed somebody a diet that is incompatible with their human biology? Is there any surprise that you get chronic diseases and weight gain and obesity and all the rest? To me, it's not. All right, so let's get into kind of the, very quickly, right, I don't have that much time left. But this, if you followed what I've said so far, this makes perfect sense. Biologically, historically, right, it makes sense that, what about a low carbohydrate, high healthy fat diet? Because we have 3 macronutrients, right? And we said, well, carbohydrate raises insulin the most, fat the least. So let me get my insulin levels low. And so this is what about this type of diet? And so it makes sense, but is there any evidence to show that it actually works, right? Yes, there is quite a lot, right? So bang, 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 bang. These over here, these are meta-analyses. Meta-analysis is kind of the gold standard. That's when there's been so much done on that particular topic, authors go out and they synthesize all the information. And basically what all these different meta-analyses are showing is, yes, low carbohydrate, high healthy fat diets do cause more weight loss, much so more than compared to low-fat diets. And the health outcomes are also better. Let me just show you quickly a couple of individual studies, okay, just to kind of drive home this point. So this study, and all these studies that I'm about to show you, were very well controlled for, published in best medical journals. And so this one, they compared a low carbohydrate diet to a Mediterranean diet to a low-fat diet. So look over here, and you can see this is over a 2-year period, right? So a long period of time on these 3 diets. You can see the low-carb diet, they lost the most weight, Mediterranean second, and in 3rd place is this low-fat diet. Here's another study where they randomized people to either a low-carb diet or a low-fat diet. So if you look over here, the top left, you can see the low-carb diet, over a 1-year period, it resulted in significantly more weight loss. Here's another very famous study. It's called the A to Z study, where they compared, say, the Atkins diet to the Zone, Ornish, Learn diet. Atkins diet is more of a low-carb, high-fat diet. The Ornish diet is a very low-fat diet, very low-fat diet. And so the author of this study, the main author of this study, when it came out, he said it was a very tough pill for him to swallow because he was a vegetarian for most of his life. And reason why is because, again, in the Atkins diet, they lost, I think, on average 10 pounds versus the Ornish diet, it was only 5 pounds. Plus, all their markers of their cardiovascular health and metabolic health all improved. Here's another excellent study, very well controlled for, and they took like 40 people with metabolic syndrome, and they randomized them either to a high carbohydrate diet or a high fat diet, where 60% of the calories is coming from fat. And again, you look down here at the bottom, if you're just interested in weight, body mass, abdominal fat, again, was better, significantly better, right, on the low carbohydrate, high fat diet. Here is just an example of all the evidence, okay? So what you see over here to the left, here's a table that contains about 60, close to 60 randomized controlled trials. So in terms of when you do research, randomized controlled trials is the best type of evidence. So there, over the last couple of decades, there's been about 60, that's a lot, 60 of these studies where they have compared low-carb diets to low-fat diets. And that's what you see over here. This is just looking at the amount of weight loss on the low-carb diet versus the low-fat diet. You take a look to the illustration there to the right, because that shows you where's all the evidence. On what side is all the evidence? All the evidence, this is unfair, right? I mean, look, all the evidence is on the low-carb side. The low-carbohydrate, high-fat diet is resulting in greater weight loss or statistically significant weight loss. You look over there to the low-fat side and you go, oh my gosh, where's the evidence that a low-fat diet is going to result in weight loss? It's like it's not there, right? And this is really interesting. This is a brand new study that was published like 3 weeks ago. And it was a very popular study that came out. So the media had a lot of interesting headlines. So I stole one of their headlines that said, low-fat diet could kill you. So this was like they looked at how people ate in over 18 different countries in over 135,000 people. So very large sample size. And let the author of this article speak for itself. They said a high carbohydrate intake was associated with a higher risk of total mortality, meaning death, whereas total fat and individual types of fat were related to lower total mortality. Total fat and types of fat were not associated with cardiovascular disease, heart attack, or cardiovascular disease mortality, whereas saturated fat had an inverse association with stroke, meaning the more saturated fat, decreased risk of stroke. And they finished by saying global dietary guidelines should be reconsidered in light of these findings. When I read this article, there was one thing in here that really stood out to me. And that's if you look over here, this illustration to the right over here, that looks at energy coming from carbohydrate. As soon as these people's carbohydrate intake reached about 60% or greater, so if you're consuming a diet where more than 60% of your calories is coming from carbohydrate, look at this line. This looks at mortality. It significantly starts to shoot up. You combine that with the fact, if you go see most nutritionists today or most healthcare practitioners, you ask them, how should I be eating? They said, well, at least 50 to 60% of your calories should be coming from carbohydrate. Then I look at the study like this and I'm going, well, it seems that if you're advocating and recommending that type of diet, you're advocating lower life expectancy, right? All right. And then the last thing very quickly is, so we clearly see there's a bunch of, from a dietary perspective standpoint, if you want to lose weight, try to cut the excess carbohydrates from your diet. And then the other solution very quickly is intermittent fasting, okay? Intermittent fasting, again, this has biblical roots to it. But if you go back in human history, there would be periods of feast, famine, feast, famine, feast, famine, okay? And it's just that most of us don't do it today, right? I mean, again, Jesus went into the desert, right, fasted for 40 days. But if you say this to a person, they go, no, that's nonsense. I can't do it, right? Because industry has plowed that message into your head that goodness forbid you skip a meal because then you might die, right? Again, it's nonsense. So, right, because here's the whole idea, right? How can I get my insulin levels low? Well, I can eat less carbohydrate. Or how about this? I cannot eat at all, right? If I fast, right, every time you're not eating, you are fasting, there goes your insulin, right? Is there any evidence to show that, again, of intermittent fasting? And there's all kinds of different intermittent fasting protocols. Is there any evidence that doing intermittent fasting can result in weight loss? Yeah, here's just one example. In this study, it was a 70-day, 70-day alternate day fast, meaning one day they ate normally, the next day they fasted. And then they ate normally, and the next day they fasted for 70 days. So look at day one. Day one, their weight, this is in kilograms, right, versus day 70, right, they lost a significant amount of weight. Do you think you're going to lose weight if you don't eat? Of course. And it's got nothing to do with calories, because once your insulin levels goes down, it promotes fat burning, and you lose weight. All right, and again, if you look at the research, there's so much research coming out that's showing you that intermittent fasting is not just for weight loss. The cancer research that's coming out is really amazing. There's all kinds of, your whole body, whether it's your brain or your heart or your muscle or your liver, is benefiting from you occasionally not eating so frequently, okay? But again, here's why people don't fast, okay? This is why people don't fast, okay? And these are myths, meaning there's not good evidence to say that's true, right? People think, I'm going to go in starvation mode, I'm going to burn muscle, my blood sugar is going to tank, and it's going to result in overeating. I got some studies over here that shows you that is not the case. In some cases, it's basically the opposite. It doesn't happen, right? But so we can talk about that later, but those are our myths. It does not happen. Imagine if it was true. Right? So go back a couple thousand years ago when food was not available so frequently, right? So you were like, oh my gosh, I'm so tired, I can't go get any food. How would we all be here, right? Come on, we just have to think about it. So here, if you want to take anything out of this talk, here you go, basics of good nutrition summarized. So, eat whole, unprocessed foods. Eat real foods, right? Eat real foods, right? And try to eliminate the processed stuff out of the diet. The sugar, the flour, the grain-based products. Try to rid that as much as possible out of the diet. That should be something occasional. It shouldn't be a regular thing, right? Again, eat a diet high in natural fats. There's nothing wrong with eating a diet high in natural fats. It's very healthy. Not processed fats. Right? That's the stuff they make in the factory. That's trans fats. Natural fats is very healthy. Your body needs these fat-soluble vitamins on a daily basis. Okay? And then lastly, right, balanced feeding with fasting. So in conclusion, right, we have a chronic disease epidemic. We have an obesity epidemic. And it's diet. Diet is the ultimate cause of all this. And unfortunately, many public health officials and organizations are providing you guys, the public, with the wrong information. It's just making things worse. So remember, obesity or weight gain is a problem of biology, not behavior. So the evidence indeed supports the mantra that food can be the most powerful form of medicine or the slowest form of poison. And most people in this country, but also worldwide, are poisoning themselves on a daily basis by the food they are eating. So let's follow Hippocrates' advice that he said a couple thousand years ago. He said, let food be thy medicine and medicine be thy food. And let's start off by that, again, by eating, again, low carbohydrate, high healthy fat diets, and also practicing intermittent fasting. Thank you, guys.